Dear students, today we are discussing iterated Riemann integrals on cells. So we have to consider two lemmas for the proof of iterated integration. That is integration with respect to both x and y in the case of bivariate random variable f of x comma y. So let us consider this lemma. Suppose that f is a real valued function and continues on C to AB, that is a cell. Define a function g of x2 as g of x2 equal to integral a1 to b1 f of x1 comma x2 dx1. So we are considering a bivariate function f of x1 comma x2. The domain of the definition is C to A comma B, as we have seen in yesterday. Then g of x2 is continuous on A2 comma B2. Okay, then g of x2 is continuous on A2 comma B2. So we have to prove that g of x2 is continuous when f is continuous. Okay, whenever f is continuous, we have to prove that g is continuous. So for the proof, we consider we have given that f is continuous on the domain of the definition C to A comma B. Okay, and moreover we have assumed that since it is Riemann integration, the interval or the domain of definition will be considered as closed and bounded. Okay, so we know that a continuous function defined over the closed and bounded interval is uniformly continuous. That is a integration result. So f is automatically uniformly continuous. The reason is the domain of the definition is closed and bounded. So by using previous theorem, we have the continuous function defined over the closed bounded interval is uniformly continuous. So we can therefore find, so given epsilon greater than 0, there exists a delta greater than 0 such that mod of f of theta minus eta less than epsilon by b1 minus a1. So this is the definition of continuity. It is less than, instead of epsilon we used epsilon divided by b minus a1. This is an arbitrary small number. Okay, whenever we take epsilon arbitrary, it will be an arbitrary small number. So if norm of theta minus theta less than delta, we use the norm because we are considering the vectors. Okay, where theta equal to x1 comma x2 prime and eta equal to y1 comma y2 prime, and x1 comma y1 belongs to x axis or the one of the axis a1 comma b1, and x2 comma y2 belongs to the vertical axis. One is in the horizontal axis, x1 and x2 are in the horizontal axis, and x2 and y2 are in the vertical axis. Okay, it follows that when norm of y2 minus x2 is less than delta, then what happens? You know what is norm? You know the Cartesian norm. Okay. Let us consider the norm. What is the formal definition of a norm? In the case of two-dimensional case, we know that norm is nothing but, this one, norm of x1 square minus z1 square plus etc. z1 square, if it is taken from the origin. Okay, this one, okay. But if we take from if we take the difference between 2 points, what happens? The norm will be root of x1 minus x2 square plus y1 minus x1 square plus y2 minus x2 square. Okay, I will show you by example. ഇപ്പോൾ നിങ്ങൾ ക്ലാസ് ഉണ്ടോ? ക്ലാസ് നടന്നുകൊണ്ടിരിക്കുക? ഓക്കെ ഓക്കെ ഓക്കെ. So I will show you the example. Yeah. What will be the form of the norm? Yeah. It will be something like, what is that? y1 minus x1 square plus y2 minus x2 square. If it is less than delta, what happens? If it is less than delta, what happens? Yeah, this will implies that, this will automatically imply that, what is that, mod of y2, one of the component will be less than minus x2, will be less than delta. Okay, so sorry, it will not be inside the, it will be outside of that. That will imply that, yeah, y2 minus x2 will be less than delta. So that is used here. So in that case, we can take the difference and mod. Therefore, modulus of g of y2 minus g of x2 exactly equal to modulus of integral a1 to b1 f of x1 comma y2 minus again integral a1 to b1 f of x1 comma x2 dx1. And we have combined both the integral, and so we have written like this, that is modulus of integral a1 to b1 f of x1 comma y2 minus f of x1 comma x2 commonly and dx1. Okay, that is less than or equal to, you know, the property of modulus. Okay, so that will be less than or equal to integral a1 to b1 modulus of f of x1 comma y2 minus f of x1 comma x2 modulus dx1. Okay, so but we have taken that f is continuous. Since f is continuous, this difference, the difference inside this function, okay, this difference will be less than epsilon by b1 minus a1. What is the reason? We have considered f is continuous, so we have taken like this. Okay, so that is we have put that result here, and we obtain that. Yeah, but also we know that this norm is exactly equal to, what is that, since the first points are same, x1 and x1, for x1 difference x1, that will be 0. Okay, this function, if we put instead of y1, if we put x1, this will be 0, and we will only have y2 minus x2. Okay, so that is taken outside from the root, so we will get only modulus of y2 minus x2 less than delta. Okay, so yeah, we can integrate this one. Okay, what is integral a1 to b1 epsilon b1 minus a1 dx1? So this is a constant term. This is a constant term. Okay, this term is no, this is constant and this is also constant. So what happens? We can take outside, and what we get? Epsilon by b minus 1 a into integral a1 to b1 dx1. So that, but integral a1 to b1 dx1 is nothing but b1 minus a1. So the epsilon by b1 minus a1 into the integral part, that means b1 minus a1, that is both are getting cancelled. So the remaining term is only epsilon. So that we can write it as, I will show you that. Yeah, integral a1 to b1, integral a1 to b1 epsilon by what is this? b1 minus a1 b. Hello, അല്ല എത്ര ഒരു ബുക്ക് ഷൈൻ്റെ അടുത്ത് മേടിച്ചിട്ട് വരണം കേട്ടോ, വരുമ്പോൾ കൊണ്ടുവന്നാൽ മതി കേട്ടോ. ഓക്കെ, മറക്കല്ലേ. dx, that is exactly equal to, what is that? You can take the copy of this one. Okay, okay, what is this? This is nothing but this is exactly equal to epsilon. Okay, sorry, b1 minus a1, b1 minus a1. So that will get cancelled with this term. Okay, that will cancel with this term, and the remaining term is only epsilon. Okay, so that is coming here. If y1 y2 minus x2 is less than delta, because we have the x1 term is disappeared. Hence, so whenever we obtain the result that whenever mod y2 minus x2 less than delta, then g of y2 minus g of x2 less than epsilon. That is the continuity property of g. Okay, so from this result we can say that g is continuous on a2 comma b2. Consequently, you know that the continuous function is Riemann integral and monotone function is Riemann integral. So here we obtain that g of x is continuous. So g of x2 is automatically Riemann integrable on a2 comma b2. Okay, that is integral a2 to b2 g of x2 dx2 exists whenever g is continuous and the interval is closed and bounded. Since the domain of definition is closed and bounded, the univariate interval is automatically closed and bounded. So in this case, by using the Riemann theory of integration, univariate case, we can say that integral a2 to b2 g of x2 dx2 is exist. Okay, so we call this integral as integral a2 to b2 gx2 dx2, that equal integral a2 to b2 integral a1 to b1. What is exactly g of x2? We can substitute g of x2 there. That is exactly integral a1 to b1 f of x1 comma x2 dx1 dx2. Okay, so that result is proved here. So this is exactly iterated integration. First of all we will integrate with respect to x1, and then we integrate with respect to x2. Similarly, we can find the reverse integration. Okay, first time we can integrate with respect to x2, then we can integrate with respect to x1. That is also possible. So next aim will be what in this theorem we have proved that iterated integration exists. That means the left side of 7.64 exists. That means right side of 7.64 exists. So next aim of the result will be, what is that? Yeah, this is equal to the double integral. So okay. Next aim will be Fubini's theorem. What is Fubini's theorem? Fubini's theorem says that if we integrate with respect to x1 and integrate with respect to x2, and in other words, we can also integrate the function first with respect to x2 and then with respect to x1. Then both double integration will be equal if f is continuous. Okay, if f is continuous, the both integration, that is first integration is first time we will integrate with respect to x1 and then x2. In the second type of integration, we will integrate with respect to x2 first and then x1. Hello? Sorry. 38. അതേ ഉള്ളൂ, മറ്റേതുണ്ടാവും. ഏത് ഡിസ്റ്റന്റ്? അതേ ഉള്ളൂ 3 4 ആറ്റേ ഉള്ളൂ. 3 4 ആറ്റ 50 പേര് 50 ക്വസ്റ്റ്യൻ. ഓക്കെ, അത് തന്നെ ആയിരിക്കും. നോക്കാം. മറ്റേ ശരി, മറ്റേ റൂം നമ്പർ ഒന്ന് പറഞ്ഞു കേട്ടോ. ഓക്കെ, ശരി. So this result is not proved here. Actually, it is proved in book of Royden. In the previous syllabus, we have studied, or we are studying that Fubini's theorem in detail using Royden's theorem, Royden's book. So this is a generalized Fubini's theorem. Case of n-dimensional case, so you just write that in this form only. Okay, so in this results we have only 3 results. That means first result is iterated integration exists. Second result is iterated integration will be exactly equal to the integral value of the function. So this can be the left side of this theorem can be represented as, in the case of 2-dimensional case, this is actually this will be 2-dimensional and function will be some height. So when we consider volume, okay, we can see that we are doing this iterated integration, or we can find out the volume directly. Okay, how can we find the volume of this yeah, here it is clearly mentioned. Length into breadth or width, length into width into height. So length into width, that is actually the area of this region. Okay, and when we multiply height with this area, we get the volume. So that is the idea of this integration. Okay, left side integration, that is the idea of this integration, area into height. Okay, but in the case of iterated integration, what happens? In the case of iterated integration, what happens? We integrate, Where is that? We integrate f with respect to x-axis. That means when we come to the figure, we integrate this function with respect to x-axis. That means we are computing this area of this part. Okay, area of this part, and then multiply with the or integrate with respect to y-axis. Okay, I will show you, then only you can understand the concept. Yeah, let us consider this region. Yeah, I think almost the same. Okay. This much is required. First of all, we will compute the area of this region. Okay, that is exactly, the region is C2AB. Okay, then we will integrate the function in that region. That means we are computing what is that? We will multiply with this height. This is exactly what is that? You can find, what is that, the volume of this. This is exactly okay. Volume. Equal to into F. F is actually is equal A into B into F. Okay, this is the y-axis, that is the height. This is x-axis, that length is A. This is y-axis, length is B. So what is the volume? Volume equal to, volume of the cube is equal to area into height. That means AB into sorry. This is F, this is A, this is B. So we can find out the volume as A into B into F. Instead of finding area first and integrating integrating F with respect to that area, we can again consider, what is that? First of all, we can consider area of this part. Okay, area of this part. What will be the area of this part? Yeah, A into F. A into F. A into F, and we can integrate that area. That means we can add area from throughout the B axis, okay, or Y axis. So we will get total volume. Okay. So in this case, how can we write? Yeah, volume equal to area into length breadth. Sorry. That is exactly equal to, what is area of blue region? A into breadth, that is B. Okay, this is also volume. Okay. Similarly, we can find out another pattern, or use another pattern. That is, first of all, we will find out area of this part. What is the area of this part? B into F. Okay. Then integrate with respect to x-axis A, throughout A. That means add through this region. Okay. We get volume, same volume. So what is that? Volume can be written as area into length. So in three ways we can find out the volume. So what is the theorem says? Yeah, in this lemma it says that the double integration exists. In this theorem it says this double integration exactly equal to the actual volume. That means we have used the methodology 1. Okay. And what says Fibonacci theorem? If we find out using first method, if we find out using this is the first method, this is first method, this is second method, this is third method. So all these methods will be equal, or we will get the area same by using three methods. The condition is, required condition is, f is continuous on C to A comma B. So whenever f is continuous on C to A comma B, so this both type of integration are equal. Okay. What is the three type of integration? Yeah, this is the region for finding volume. First we will take the area, and then we will multiply with height. So we will get the volume. Okay, we will get the volume. The next method is, we will find out the area of this part, then multiply with the B, we will get the volume. Okay. In the third method, we will find out this area, and we will multiply with the A, we will get this volume. Okay. So these are the three methods. So I think you got the idea. The theorem is not proved here. At the same time, you can see the proof in the book of Royden. In the previous syllabus, we have proved that result for as part of their syllabus. In this syllabus, you need not to worry about the proof, but at the same time, you try to understand the concept. If you are interested, you can go to the proof of this theorem using the book of Royden. It's very simple proof, but you can use that book for the proof. Okay. I think you try to listen this class, and if you have any doubt, you may ask to me when we discuss later. Okay, you can ask the questions, and you can clear the doubts. Okay, no problem. I will try to answer that.